And now here I am at CCAT and making boss moves coming out of sort of a unique situation of having an opportunity to be what do I want to be when I grow up, right? And so it's an opportunity for me to still stay technical, but be that woman in tech and work with the phenomenal team that we have at CCAT with leading edge technologies, supporting the workforce, powering the workforce of the future. It's incredible. So I'm so thrilled to be here. I'm coming up on 1 year.
Yeah.
And it's just been an amazing journey.
Just a quick reminder for you to like, subscribe, and rate this podcast so we can get your feedback and know how to make it better.
Hey, it's Ari. Welcome to an on-site episode of the Made in America podcast. I'm really excited to have Jacquelynn Garofano on. She's the CTO at CCAT. Jackie, thank you so much for coming on today.
Thanks for having this episode in this cage. I'm really excited.
I know we've been joking, calling it the cage match episode. Nice. Well, listen, Jackie, it's the Made in America podcast. So we are going to start off with the same two questions.
Yeah.
What do you make and why do you make it?
So knowing that I was coming on here, I wanted to take the personal route, but I'm going to save that for later.
Okay.
So what I wanted to talk about is what we make here. We're housed at Goodwin University. This is CCAT's Advanced Composites Technology Center. We are making complex composites for aircraft engines. So here, it's this monstrosity of an Industry 4.0 showcase. So the benefit of why we're doing this, why we're making aerostructures out of composites, is for lightweighting.
For lightweighting. Mm-hmm. And also to build up the supply chain and to
Exactly.
drive things forward technology-wise.
Yeah, all of those other things. Yeah.
Listen, I think that's awesome. And we have a lot of, we have I was going to say wood to chop, but maybe composites to build around what's going on at CCAT and what this machine's about and what the Composite Center is doing and how it's engaging with the manufacturing ecosystem here in Connecticut and workforce development. There's tons to do that. But let's do a little personal first.
Okay.
All right. So let's talk about kind of your journey, into manufacturing and ultimately to CCAT. So why don't you help the audience know, what's up, Jackie? Where are you from? How'd you get here?
I'm originally from Milford, Connecticut. So I'm a Connecticut native, born, bred, educated, and employed.
There you go.
I don't think I'll ever leave the state of Connecticut. I like to tell people that our roots are planted here, my husband and I. So I'm also first generation. I don't have any engineers or lineage of people that have ever gone to college in my family. So I also think that I could talk to people about being a late bloomer, which means that I came up in the 90s in public education in high school, bio, physics, chemistry, astronomy. I had a love of physics and astronomy because I wanted to be an astronaut. I wanted to go work for NASA or be in an observatory somewhere. So, thinking about what to do, what's the next step after high school, going to college. So thankfully, I was accepted into the Honors College at Southern Connecticut State University. And that really was a life-changing moment because there I met Dr. Christine Broadbridge, as a freshman at the open house. And I was inquiring about what it is that you do. She was starting up a lab. Again, I had no previous experience, no one to really even go to be I want to be exactly like you. She was that for me. She was that catalyst. She set me on my path. She took me under her wing. I started to do materials research as a freshman and a sophomore. I was working with students, postdocs, and faculty at Yale University because there was a National Science Foundation Center that she established there. So my love of being a researcher, doing hands-on experimental work, brought me to then University of Connecticut. So I didn't become an engineer until grad school, and going from being a physicist to an engineer was kind of mind-blowing.
Yeah.
Because although the language is the same, I think ebonics in that way, there's different ways in which you talk about thermodynamics, and I didn't know what a stress strain curve was, so there was a lot of learning for me, which is great because I'm a lifelong learner. I want to just be inspired and want to be able to, figure things out along the way. So again, continuing to do research, I was accepted into the PhD program at UConn to study material science and engineering. I was, studying nickel-based superalloys. So all of my research as an undergrad led me to grad school and then ultimately landed me a job at United Technologies at the Research Center, the think tank of UTC where a bunch of PhDs were working. And thankfully, because I had really strong mentorship and a great network, I was able to easily navigate my way through academia to my professional career. So in doing so, I had become a research scientist at UTC, working on all of the different products that the company was making at the time. You think Otis elevator, Carrier with fire security controls, Pratt & Whitney with the jet engines, and then, of course, whatever now Collins Aerospace was at the time. There's been a lot of change through that organization, that business unit. So I was doing a lot of failure investigation, technical support. Just-in-time learning, on-the-job training is something that even I needed as a PhD graduate, because I was so used to doing research on one thing for 5 years that then when you hit the workforce, you're like, WTF, what is this, right? I have no
Why?
idea.
Because the pace, the speed is like so much faster.
Even just like there's so many different products, components, systems, in a corporation like UTC, when you have such a diverse portfolio, so many things can cross your desk, especially when the manufacturing process needs support with technical, problem solving, or something comes out from the field. There's aircraft are grounded because something is not working and we need to go and problem solve. I was literally using a really big microscope and studying really small things as a grad student. And that's so microscopic compared to the big wide world of a corporation like United Technologies. But the great thing is you need to be able to think on your feet, have critical thinking skills, communication skills, knowing the right people to go to help you solve your problem. So I myself never considered myself to be narrow and deep, right? There's people that are technical experts in this.
Right.
Similarly, there's composites experts. I never really aspired to have that on my path because I touched so many different things, as a materials engineer. So I had a breadth of experience, and I just wanted to, I have a GSD attitude, right? I just wanted to be able to solve problems and just continue to innovate and make change and, do a lot of things, not really be tied down. And I also thought of myself as a people leader. So you have folks that are really strong technically and want to just be that technical fellow, that tribal expert, that person that is the penultimate of that area.
Whatever that one specific little thing is, not your bag.
No. My whole thing was I wanted to really just make an impact, again, really focused on the state of Connecticut. So cultivating our next generation is something that I've always been very inspired by because I had Christine and I wanted to be that for her. So I went through this whole evolution of, branding myself even later on in my time at UTC, like, where am I going in an organization this big? What is it that I really want to do? And thankfully, there was an opportunity to stand up an engineering leadership development program. And I read that job description, and I was sort of done. I became a glorified PowerPoint engineer, as many of us do in that time where you're not really being a manager or department leader or where you are in the ranks. So
Meaning like what? You're in other words, you're sort of putting together presentations of the results of things.
You're collecting the data from those on the team that you're collaborating with and then communicating that to your customers. Or you're trying to go after opportunities for federal funding or otherwise.
So you sort of found yourself in a position where you were, not only were you like not getting to be the penultimate depth of something, which you didn't want anyway, but now you're not even really so much hands-on.
I wasn't being
You're
technical.
sort of like, you're sort of like the go-between of sharing the results or looking for funding. So kind of not betwixt and between of even what you wanted to do.
Yeah. And there's that path, right? That fork in the road. And so I had an affinity for, organization and really making a difference for a business. And so I had an opportunity to become a people leader. And the people that I was leading are truly next generation leaders that are, now the organization is Raytheon Technologies. But it was so inspiring to just be able to hire in talent into our organization, high potential talent, solid engineers who had amazing executive presence, even so young. They're a generation younger than me. And I was just so inspired, and literally it was the best job ever. So I did that gig for a couple of years, but then we had the integration with Raytheon Technologies, and Raytheon had a similar program that was 20 years old. And so it just, with convergence, it was my time to leave the organization. So I didn't really know what I was going to do. I looked at it as an opportunity to reset, right? Like I haven't been technical really in a while. Leadership is incredibly important to me, and I wanted to really be ascending into the ranks wherever it was, and knowing that it wasn't going to be in a large organization like Raytheon. So thankfully, because I've built up a network and I feel like I've been a bit known in the Connecticut community, Ron Angelo knew that I was coming up on the market and had, pinged me and said, let's talk about what you want to do next in your career. And after a few months of having conversations with Ron, he appointed me CTO of CCAT, and it's really my third time working with the organization,
right,
because I was doing research. That graduate work at UConn was those nickel superalloys were being drilled at the laser lab at CCAT at the time. I worked on a program with my predecessor, Tom Maloney, the former CTO of CCAT, on an America Makes program, a federal program with a lot of different collaborators. And now here I am at CCAT and making boss moves coming out of sort of a unique situation of having an opportunity to be what do I want to be when I grow up, right? And so it's an opportunity for me to still stay technical, but be that woman in tech and work with the phenomenal team that we have at CCAT with leading edge technologies, supporting the workforce, powering the workforce of the future. It's incredible. So I'm so thrilled to be here. I'm coming up on 1 year.
Yeah.
And it's just been an amazing journey.
So it just seems like this position kind of becomes the culmination of everything you've done before, right? It's going to leverage your deep understanding of sort of like, results-driven research, right? Like here's the hypothesis, here's how we're going to go and try and get there. And then so measure our results, go back, try it a different way. And I know we're going to talk about the composite machine, that we're sitting inside of, right? It's so big. And I think that's really cool. But then it also is going to leverage some of that presentation skills, right? Mm-hmm. Because what we're doing here is really, I don't know if prototyping is not the right word, but it's really like sort of proof of concepting to say, this is how this can work. And then it's going to be making sure that it meets the needs of the end user, and then also showing people how to make it and how to make this part of their business. And then on top of that, it's going to be training people on how to operate these things and help build the workforce of the future who can go into the supply chain in Connecticut and sort of say, this is how you make these big machines work. So you're kind of taking all of your experience starting at Central all the way, through UTC and putting it to good use here. That's pretty awesome.
It is pretty awesome. Yeah. And I've always kept an open mind and an open door. So I never really had an end goal in mind, although I did share with you that I wanted to be a leader.
Right.
Whatever that means, whatever walk of life, whatever title that brings. But I'm grateful that Ron, trusted in me to come on board and really drive the team in the direction that we're going. And so it's been an amazing year that we've had at CCAT and a lot of really exciting momentum ahead of us.
Nice. Well, I'm going to kind of pivot to, let's just kind of introduce what we're in. So you mentioned that we're at the Composite Center, the Advanced Composite Center, which is at the Goodwin University campus, but run by CCAT. So I don't know how big this machine is, but this whole setup's pretty big. Maybe you could sort of, just for people that even the people that are watching this on YouTube right now aren't going to really be able to get the full scale of what this is. So maybe describe kind of what it is, how it works, and why it's so important to the supply chain.
Yeah. So behind Ari is an Ingersoll, a KUKA robot that's multi-axis. And this thing is probably approaching 2 stories tall. It's multi-axis, so it goes and moves not only the tool, which you see here, which is where that square piece, and I'll get to that in a moment, but it also moves along so that way this whole cell is an Industry 4.0 showcase. It's automation, robotics, in-process monitoring, the whole manufacturing setup done in one swoop. So what we have here is the tool actually is placed on that square, and then the tool will be in the shape of a complex geometry that would go into an aircraft engine. This is the gantry system here. So this is where we have the they're called TOWS, TOWS, and they're layers of composite material, pre-pregnated carbon fiber and polymer material. There's 8 of them that come out of this, little roll there, and most people are familiar with carbon fiber woven composites, right? You see a lot of them in automotive, and this technology is not woven. So these toes are aligned adjacent to each other. They're heated and compressed along that complex geometry. And then this gantry system will then move in different angles according to what the design requires. So again, we're building three-dimensional complex geometries of aircraft components. So all of this happens, because we have an engineering team that's outside of the cage, that's putting together the design. The in situ processing happens. The process monitoring happens because we have laser systems that will identify if there's any gaps or delamination, or there's not carbon fiber.
How tight is that monitoring? So just to help maybe put some clarity on here is so what we're ended up doing is we've got the toes that are going to be this composite material.
Yep, they're laid up into plies, and they could be stacked.
And then they sort of stack on top of each other, and then they connect to each other. And so again, you won't be able to see it, but I don't know. There's something, I don't know, but this looks like a paddle maybe, but it's actually really solid and really strong. And if you look at the sort of the cross section of it, you can just see. I don't know how many layers are sort of laminated in there, but that all sort of happening, and how that's happening on the back end is somebody drew something. I don't know if it's in SolidWorks or whatever.
Correct, yeah.
But is it SolidWorks?
Yeah.
Yeah. So someone drew something in SolidWorks, loads it into a computer, and then tells the machine, go build it.
Right.
Then the machine just starts building it on its own. And we've got cameras, we've got lasers that are all monitoring. What are those cameras and lasers doing during the build process?
They're checking to see whether or not what the computer tells it is happening. And so it's very fine resolution because, again, we're creating structures that ultimately go into an engine that will ultimately carry people. So these are, really important structures to not have any sort of issues. What the in-process monitoring can do is to then flag, stop the process, tell the engineer, in this area you have some sort of issue that needs to be addressed. And sometimes it's an easy fix, or sometimes you need to just kind of remove those layers, and then go back to the drawing board and then start again. So what it's creating is an opportunity for us to really move fast in that way, because it's all driven by connectivity and computers and automation. With the intervention and the human power of the Pratt & Whitney engineering team that's collaborating with our CCAT team to be able to develop these complex composite structures.
And so why do it this way? What's the advantage of, I'm sure this machine's not inexpensive. This whole setup, again, I don't know, what are we, 35, 40 feet across inside the cage? It's
probably,
it's big. And like you said, almost 2 stories tall, all kinds of different parts, not to mention the computers that power it. So kind of what's the why? What's the ROI behind doing it this way versus the more traditional way?
I think more traditional ways in a lot of manufacturing are not up to snuff, right? We're in a new revolution of leveraging automation, robotics, computer design, and, it allows us to be able to, just make things more efficiently, better, with less, there's a lot of tribal knowledge that many folks in whatever area of manufacturing or technology, they are the tribal experts, they know. But this now allows us to be able to push this technology. It's more attractive to our, upcoming generation of talent. It allows us to be able to, move faster in a way that I think will support the supply base in a much more meaningful and impactful way as we move forward to the future.
Can we make the parts faster this way?
Yes.
Really?
Yes.
Are they stronger?
I don't have numbers
better?
on that.
That's okay. Yeah. That's why we're in the research. But just basic questions, right? Are these composites and building it up this way, versus sort of the metal alloys that we do the reductive manufacturing through? Are these stronger, same strength?
Yeah, you've hit a good point. So additive manufacturing in whatever material system is the new wave. It's been new for probably a decade or so, and we're getting more. We're getting better at really adopting those technologies. So in our Silver Lane site, we have all of those metal and polymer additive, technologies. Here, we're really focused on these type of composites. What we're able to do is as you rightly said, instead of subtractively, taking a hunk of material and machining it away, creating waste, we're able to create near net shapes of whatever this geometric shape is that we want. We're reducing waste. We're really, using the material as it's needed to have a fit, form, and function that's near net. So we're eliminating much more of that processing, that post-processing that would, be more potentially degradation.
Near net meaning when it comes off this machine, we still probably have to do some machining.
Yes.
But like far, far, far less than we'd have to do the other way around.
Correct. Yeah.
What about the strength of the material?
So carbon fiber is renowned for being a material that's incredibly strong and tough and certainly lighter weight. So a lot of times we have, I talked about super alloys, right? The mixed soup of all these different elements that are metals put together. Those metals are heavy, so the goal of going to composite structures is lightweighting. I mean, you're picking up that paddle and you're like, oh man, this is still quite heavy, but it's lighter than it would be for, if that was made out of, nickel or another type of metal. So you equate lightweighting to fuel saving. It's not only good for efficiency and cost savings, but the way in which Pratt & Whitney is really moving towards the future with sustainable aviation fuels and really their geared turbofan engine. I mean, we're really just transforming the way in which we're manufacturing and being more conscious of sustainment and environmental concerns as well.
Meaning so in very basics too, I mean, yes, you going green too, but if it's lighter, it's cheaper to fly it.
Correct.
So that's another big thing. So how close are we to taking something like this and operationalizing it to be sort of like production ready? Like I know we're making parts, but to make the stuff that would actually go into an aircraft engine or go on a plane.
So in talking with the team, it's, there's a roadmap which probably has a few years out of being in that forecast. There's talks, and I was even just talking to Alan Salisbury, who's one of the leaders on the Pratt & Whitney team, that they're going out and looking at suppliers to be able to take what the development team has been doing here and standing up that supply base elsewhere. So it's probably within that 2 to 3 year window. I mean, for production, there's a lot of testing that happens. And even here at Goodwin University, this used to be an old Pratt & Whitney facility. So, in my time at UTC, I had a lot, you hear all of those stories about, bird injections and throwing the Thanksgiving turkey, that ingestion. So there's a lot of testing that even it needs to happen, right? Because these are really critical components. So I don't have an exact number, but I would think we're still a few years out.
Couple years away. Mm-hmm. So talk about we're sort of talked about the technology, but we also talked about engaging with the workforce to try and understand this new technology. So where are we in that process? I know there's CCAT staff that operates this. Talk a little bit about how we're going to help train people on this new technology and help them embrace it.
A part of it is that inspiration, providing students with a spark. So here at Goodwin, we have windows that are not frosted. So the students walk by this lab and they see this amazing robot and they see our team working. So hopefully that presents some inquiry of what is actually happening here. So there's that piece of it. But then there's also the team of individuals across the state of Connecticut and the academic institutions that are working to create curriculum to then take into the university system and teach engineers about this technology. Mm-hmm. So how to develop complex composites and what it means, structure, property, processing, all of the things that are really critical to the fundamentals of a particular material system like advanced composites. So you have Goodwin University, the State University System, Pratt & Whitney, and CCAT that are and the state of Connecticut that are all working to be able to bring this technology, this learning to our next generation. Alan was just saying that there's not enough composite engineers. And of course we hear that with every walk of life, right? Within manufacturing, workforce is of a critical need. And we have individuals that certainly are those deep technical experts that have been working in composites for decades. Then you throw in this type of automation, it changes the game of how they've been manufacturing and developing, but those fundamentals are still relevant, right? At the very base. So it's an interesting time for all of us, really, to be able to inspire our next generation, push more engineering talent into the university system. But then also, as we know, there's so many other jobs that are still needed that don't necessarily, you don't need to be like me and go to school for 9 years, right?
Right,
Come out with
right.
an advanced degree. So it's an interesting time for us to be able to inspire students, and I know you're a great champion of this, into manufacturing, into like, kids probably grew up with Fast and the Furious, right? Like, what is it? Like, what are carbon fiber composites? Like, you're going from cars to now aircraft.
Aircraft to do that. I wonder, maybe a little bit, sort of on topic, but in a little bit of a different direction, and maybe something you don't know, but I'm just sort of curious. Like, as we're looking at doing composites, I wonder, do we need to be thinking going all the way back to sort of aircraft design? Do we need to think differently about how we can design things when composites and this type of technology is part of what we're doing, sort of as opposed to using this technology to make the old designs work? Should we be thinking about new designs that leverage this new technology that could simplify the entire process?
Yeah, I think it's a force multiplier. So there's of course, a lot of smart people that are already innovating and ideating about how can we translate this into something else, right? So I'm sure that it's on their radars. Because, although, the tube and the planes really haven't changed in form, there's what certainly comes into play is a lot of the autonomous vehicles, right? Like
Right.
drones and smaller, not so much commercial or military aircraft.
That could use the different technology. So, this is great. And I wonder if we can maybe broaden our conversation, because you're not just the CTO of the Advanced Composite Center, but of CCAT altogether. So, let's just kind of reintroduce at a higher level to the audience, like what's going on with technology and CCAT in general? Like, how are we engaging with the supply chain out there? Like, just give us the heads up on that. Where are we at today?
So at our other facility at Silver Lane, we have 2 advanced technology centers that are really focused in additive technologies, which I talked about a little bit before, where we just brought in a new technology that we've coined to be called a flex cell, which is it's HRAM, so high rate additive manufacturing flex cell. This allows us not only to do those very fine, intricate designs with metal additive, which we have technologies to do so, but now getting into the larger scale, shipbuilding, maritime. CCAT, we just kicked off, I can't keep saying just. Late last year, we kicked off a Navy Mantech program with Electric Boat, focused in additive manufacturing. So this allows us to really open up a portfolio to do larger builds, right? Instead of making things that are more confined in geometry. So 1 meter cubed is kind of the large scale that we're talking about. And you could lay down wire, or you could lay down powder and wire. So that's a really awesome technology. The robot is smaller than this, but it's a really cool cell that was integrated by Force Automation in New Britain, Connecticut. So it's an opportunity for us to explore different, types of industries. Also there, and you had the podcast with Ron, that is the May 4th episode, is you guys were in the advanced design, automation, and metrology side. And we have, a bunch of robots too, much smaller than this guy here, but we're able to leverage, non-destructive testing. Myself, I came up, if I would cut that up and look at it underneath a microscope, right?
Something like that. This design, the same emitter.
But when you're dealing with the supply chain, and the needs of, particularly with respect to Industry 4.0 technologies, that side of the house is really all of that. Model-based definition, generative design, how, to your point of designing, new structures, you're able to leverage technology in order to do that, different types of software. So we have a real collection of equipment. The HRAM Flex Cell is our newest. Much of everything else we have really been focusing on to bring awareness and adoption into the supply chain. So those small to medium-sized manufacturing companies are still where CCAT focuses. Our engineering team will go out and walk the floors of companies and ask them what their pain points are and how can we help you, right? We're all about providing solutions to those companies, lifting them up and having an understanding of what what is all of those things that I had just riffed off? How can they help me in my company, right? How can I also, when we talk about workforce, engage and have all of our digital natives, all of our young talent, be able to hit the ground running when they come into a shop? I've walked a lot of manufacturing facilities in Connecticut, and it's amazing to see the really old married with the new, right?
Yeah.
So you'll have a collaborative robot arm that's helping with some ergonomic, opportunities, right? To then take that person, that operator, and put them into a higher value add, space.
What are some like success stories maybe that you could share? Obviously, maybe not with specific company names, but just some success stories. Because I think, something that I hear a lot is, I know about CCAT, but I don't really know how to engage or what to do, or, so maybe some success stories would be cool.
Sure. So one of the success stories that's, I think really awesome, and it speaks to our portfolio on the federal side from that NERDIC program that we had, New England Regional Defense Industry Collaboration. We have a whole playlist of videos on YouTube that, walk folks through introductory workshops on what these technologies are, and then those use cases from companies. So Habco Industries, Brian Montanari, had given us a challenge, a pain point for their company and their team, and we were able to use mixed reality. So we used a headset, a HoloLens headset, to be able to then take more of the manual labor, which is time intensive, and your human eye is only as good, right?
Mm-hmm.
And it could lead to some challenges after the fact. So working with our team and creating a demonstration of leveraging this mixed reality headset, saving 3x, like taking hours off of time. The task was stenciling of these containers.
Yep.
And so it's amazing what the ingenuity of just not being afraid of trying something on. So that's what CCAT's great to be able to provide.
So just to like back up, so sort of saying, if I've got a small or mid-sized manufacturer, Habco's a great, example of that, right? Have a problem, come to CCAT and say, hey, is there a technology that maybe could help me solve this issue,
Absolutely.
reduce time, reduce errors, improve quality? That's like a great use case to come to CCAT and sort of find out if there's opportunity.
And it's no cost to the company because the state of Connecticut is funding our ability to really provide technology demonstrations or engineering consultation to that company. And engineering manpower, it's a no-brainer. So
people should be taking advantage of that.
Yeah.
So I think that actually dovetails into another thing that I want to talk about. I know we're winding down on time, but I just want to touch on a few more things. Like one of them is funding. Like I know that one of the not knowing how to start the conversation is one barrier to entry, right. But the other one is the idea of like, oh my God, I don't have $5 million to invest in all this stuff or whatever it is. What can CCAT do to help companies who are trying to dip their foot into this new technology afford it?
Right. So again, the state of Connecticut is really supporting the manufacturing community. There's matching grant voucher programs that are available on the Industry 4.0, as well as just the Manufacturing Innovation Fund. So there's two different pools of money that companies can, tap into to be able to onboard hardware, software, project management. There's criteria that's there, but it's not either or. So if they're interested in Internet of Things, in integration of I4.0 technologies, there's that pathway. Plus, there's also those tech demonstrations that our engineering team is, waiting to be able to support you on. And then the Manufacturing Innovation Fund, which has been in existence since 2014, has granted over $25 million to companies. So we're subsidizing dollar for dollar in some of these capacities of helping small companies really, have more capital to be able to onboard technologies. And we will help you along the way, right? We have our engineering team that's there.
So as a small manufacturer in Connecticut, I can come to CCAT with a problem. Mm-hmm. I can get their analysis, possible product demonstration, even a walkthrough at my own factory, no charge.
Exactly.
Then if I decide we have a project we want to try, I've got one or two different options of pools where every dollar I spend up to a certain amount can get matched with the state. So basically doubling my money to help me invest. I just want to make sure I've summarized that totally correctly.
Yes.
That's pretty good.
It is. It's amazing.
Yeah, that's awesome.
And we need to keep that message going.
I'm doing my part. What do you see about workforce development? I know that, we talked about it here, kind of the workforce of the future. In particular, I think, we were trying to inspire the next generation to understand that manufacturing is lean, green, clean, high tech. This obviously helps. CCAT, certainly helps. But another big thing, and I know you're passionate about this in manufacturing, is to try and look beyond what people's like outdated stereotypes of what a manufacturing employee, looks like or can be. And I know women in manufacturing is something that you're passionate about. And I wonder if you could talk about that and maybe even beyond that, what CCAT's doing and what in partnership with Goodwin's doing to try and like expand the pool we're drawing from to help grow the manufacturing workforce.
Yeah. So I talked about personal branding, right? And clearly I'm wearing a shirt that speaks to the fact that I'm very passionate about...
The shirt, for those that aren't watching, the shirt says
STEMinist, STEM, science, technology, engineering, and mathematics. I've now nerded out and done like a square to that, adding in manufacturing.
Right.
So just, I've been in this technology space through academia and my professional career for nearly 2 decades, and it's still, the demographics are very much the same. Yeah. So, it's great that we're talking about diversity, equity, and inclusion. But, again, I always, think about we could be doing more. And it's important for us to be able to have spaces and people that look like you, right? To have the opportunity. And I'm really excited for Paul Lavoie to take the helm from Colin Cooper as Chief Manufacturing Officer, because he's very passionate about this too. And there's this groundswell of us as CCAT. The work that our team on the workforce innovation side does is go into those communities of underserved, underrepresented, and introduce them to manufacturing. There's so many success stories, and it's incredibly amazing and heartwarming to hear. It can be life-changing for someone that grew up in Hartford, right? To be able to get an education at a community college or a technical high school, and then be able to get into the workforce earlier. Again, you don't necessarily have to be a 4-year degree or beyond, right, to come into manufacturing. So having programs that specifically focus on women in manufacturing, CCAT partners with the Deloitte Foundation. And so a part of that work is to get more women into manufacturing, into welding too. I love to be able to coin the phrase torch the glass ceiling, because those women welders are amazing. We have, such an opportunity to take those young digital natives that can put me to shame, right? Can put you to shame, can put others to shame. And it's such an opportunity for us to be able to bring attention to, exactly like you said, manufacturing is not dark, dirty, dingy, right? Like, it's not what you think it is. So bringing that awareness to educators, families that have that preconceived notion about there's no career path in manufacturing. The Manufacturing Innovation Fund and the leaders across our state are really are doing the work to change that. And so I, in my role, always, show up as a woman in tech first, right? It's important. And I know because, although I'm first gen and, I just based on appearances, right? Like, there's still, I'm a white woman, right? And so my story is better than some, right?
Yeah, listen,
So,
you said I think one of the things that's so important, which is in order for someone to kind of get there, they need to sort of see somebody that they can connect to, that's been there. You had your mentor when you arrived, at Central, that set you off. Southern, sorry. When you arrived, at Southern, and that springboarded you into everything that you've done, since then. And now you get to be, that person for somebody else who can go around, and just see this badass chick with a nose ring who's like doing it, right? Like who's just kicking butt. And I think that's really terrific. I think Paul Lavoie, to your point, been great, and he doesn't just feel passionate about it, but he's got the track record of the women that they brought in, to lead Carey Manufacturing, and the turnover, the young talent that they've had there, not just gender-wise, but also racial and ethnic background. Really impressive. And I think my personal belief is our future in Connecticut manufacturing is going to be to embrace the entire community if we want to build the workforce of the future.
Yeah, absolutely.
Well, listen, we're going to go to rapid fire round of questions. Jackie, are you ready?
Yeah.
All right, here we go. Red Sox or Yankees?
Either.
Oh, Starbucks or Dunkin'?
Duncan.
Staycation or exotic destination?
Never been to an exotic, so stay.
Okay. iPhone or Android?
Android.
Sports car or SUV?
Sports car.
Do you have a favorite business book?
Brave New Work
Ooh,
by
that's
Aaron Dignan.
Aaron Dignan, that's a great one. If you had to do something other than be the CTO at CCAT, and it could be anything in the whole world, what would you do?
I'd be an astronaut.
What's something that you learned early in your life or early in your career that you think's helped propel you to all the success that you've had?
I had a work dad at UTC, and he helped me to, like, as a type A person, lower my expectations, right? So I think I would get really worked up because people were not meeting me where I think that they needed to. So being more accepting and having more compassion with others, right? And I think more so delegating earlier, right? Not being that individual contributor, like holding on, like I could do it. I could just get it done quicker, faster. Being able to empower others and trust in others. So that was something early on in my career coming out of university was like, you need to just be willing to
Let go and trust other people.
Yeah.
I know it's rapid fire, but I'm going to do a follow-up because I think people can super learn from that, which is how did you put that into action? Because I see that as a major challenge for people that are.
It takes work. It's like a muscle that you have to continue to work at, and being mindful and catching yourself or having others, like that's why mentorship is so important. Others that will call you out and keep you straight. I think that's so important.
Wow. What's something that you learned later in your career or later in your life that if you could go back and tell young Jackie, and if she'd listen to you think it'd really propel her forward?
No is a full answer, full statement.
No? Can you elaborate? No.
You don't need to make apologies. You don't need to make excuses. You can say no. And I say that because I went through a period of time where I was constantly saying yes, taking on too much, trying to really take on the world and do too much. And that causes burnout, that causes mental issues. And you throw in some imposter syndrome along the way, like depending upon, particularly from where I was. And I just had to say, time out. No, that's my answer. Because you don't owe anyone anything.
I absolutely love it. And I'm going to leave it there. Jackie,
Okay, awesome.
It has been awesome having you on. I am a huge fan.
Thank you.
Love what you're doing at CCAT. Appreciate your time today, and we're rooting for you.
Awesome. Thank you so much, Ari.
Made in America with Ari Santiago is brought to you by CompassMSP.
Thanks for listening and spending some time with me today. My goal is to help build a strong manufacturing community, and it would be impossible to do without all of you.